So on the 4-5 day 2 notes, we just have more percent work. Again, I think I'm going to run through the evens and then you can work through the odds. Um, but the major difference on this one is that you're going to have some of those tables to fill in. So if it says an electric motor uses 6 kilowatts at an efficiency of 63%, how much power does it deliver? Well, we're basically looking for 63% of 6. So 0.63 times 6 is one way of doing this. Or I can do 63 over 100 is equal to what of 6. Either way, these are going to get the same answer. It really doesn't matter which method you use. But I think this would be more consistent with what you've been doing. So, but sometimes I do this method because it's a quick way to do it. And so I would say that this is 3.78 kilowatts of power. Number 4 is one of those table problems that I was talking about, and this plus and minus 5% is just plus or minus 5% of that original. So I want to figure out what 5% of 5,300 is, and so it'd be 5 over 100 equals x over 5,300, or in this case, this would be a quick one to go 0.05 times 5,300, because I'm just looking for that little value. So 0.05 times 5300, oops, I did too many zeros on mine, I've got to do it again. So that would be 265. So what I'm going to do is I'm going to, the low end would be 5,300 minus 265, and the upper end would be 5,300 plus 265. So then I just have to do that math. This is 5,035 up to plus, so that would be 5,565. So when we talk about our tolerance is how much give we have. And so we would say my tolerance goes from 5,035 to 5,565, or I might say that I have a tolerance of, I just want to double check and see how if they write it in a different form. I don't want to give you the tolerance plus or minus. Okay, let's write it that way. Yep, that's what they like. So they like to see it in a plus or minus form. So my tolerance is plus or minus 265. So plus or minus 265, because that's what I'm adding or subtracting to that. The rest of these are kind of the same. I don't think I necessarily need to go through all of them, but I'll do one more. So I'm going to do 10%. So I would do 0.1 times 6800. That gives me 680. So I'll call this plus or minus 680. That's my tolerance. And then I'll go back to this to figure out, I do the 6800 minus that tolerance and the 6800 plus that tolerance. So $61.20 to $74.80. Moving on, trying another even. Electrical resistor is rated at 500 ohms at plus or minus 10%. What's the highest value they want to know? I can't read exactly what that says. I'm going to see if I can get, what is the highest value its resistant could have within this tolerance. So when we do that, we want to find the upper end. So I'm going to do the same thing. 0.1 times the 500 would give me 50. So my tolerance is plus or minus 50. So the high end would be when I add it, so it'd be 550 ohms. Final answer on that one. On some of them, like in problem number 8, a small gasoline shop engine develops 65 horsepower at 2,000 RPMs, and at 2,400 RPMs, its power output is increased by 25%. What is the actual horsepower does it produce at 2,400 RPMs? So what we're doing is we are going to take this horsepower here and increase it by 25%. So I do 65 plus 25% of 65. So it's what I started with and then plus my increase. So it's going to increase by 25%, but I still have to keep the initial there. So it's 65 times 0.25. I would do 65, the RPMs, plus the increase of 16.25. And so we would end up with 81.25 RPMs. Nope, horsepower. Horsepower on that. So 81.25 horsepower. What's the actual horsepower? 25% higher is my increase. Oops, don't want to do that. Again, just working through a lot of percent problems. If you receive a pay increase of 12%, what's your new pay rate? This is a similar type of problem. Assuming your old pay rate was $16.80 per hour, I'm going to start with my $16.80, and then I'm going to add my increase to this, get a little different take. All these problems you could be doing, you know, like what is 12%? I could do 12 over 100 is what out of 1680, and then get that. These two things are going to end up equaling the same thing. They would be the same value. These two are the same value, and then I would add that together. So sometimes I just like to do it again this way because I think it goes a little quicker. Plus 0.12 times 16.8. So my new pay rate should be roughly $18.82. Oops, I wrote that backwards. $18.82. It comes out to be 81.6, but you know that money is only two numbers after the decimal point, so I have to be a little bit careful on that. Okay. I guess I think you kind of get the gist. Driving into 20 mile per gallon breeze cuts the gas mileage by about 12%. So what will be your gas mileage in a 20 mile per gallon wind if it is 24 miles per gallon with no wind? So the difference here is by cutting, we're removing that amount. So I'm going to start with my 24, but it's going to reduce it by 12%. So I'll do 12% of 24. So because it's cutting it, it's a subtract. So 24 times 12% of 24, and then I just plug that in my calculator. So I get, oops, I did times instead of minus. So minus, and I didn't even put the, holy cow, I'm getting sloppy here. So I would get 21.12 miles per gallon on that problem. So that was a decrease. So the next one, number 14, a new tire had a tread depth of 3/8 inches. After 1 year of driving, it had 9/32 of thread remaining. What percent of the thread was worn? And so what I need to figure out is how much I lost here. So I'm going to do 3/8 minus 9/32, and I just find a common denominator, so that's 12/32 minus 9/32, and I end up with 3/32, and I need to figure that's my percent wear. So I need to figure out what 3/32 is as a percent of 3/8. So what percent of 100 is 3/32 of the original amount, 3/8? If you have a fraction calculator, that makes your life a little bit easier here, and I know you worked through the fraction section, so I'm assuming that you're going to be able to do that. So it's just multiplying, cross multiplying. 3/32 times 100 And then I'm going to divide that by the 3/8. And that one came out to be pretty nice, so it's a 25% wear. And then we have, again, another problem, problem number 16. When a turbocharger is added to a certain automobile engine, horsepower increases by 15%. If the non-turbocharged engine produces 156 peak horsepower, what peak horsepower does the turbocharged engine produce? Round to the nearest whole number. So this is again an increase. So I'm going to have 156 plus a 15% increase. So I'm going to start with my 156 and then the 15% of the 156. So 156 plus 15% of 156. That gives me, says round to the nearest whole number, so I'll say this is about 179 horsepower is what I would put on that. That's the turbocharged horsepower. Got another table at the end that's a little bit more of that kind of tolerance, some stuff, minimum, maximum, doing our plus and minus percentage. So the differences, I'll just pull out a couple, like I'm just going to focus on this second one here. So if I start with 0.67 inches, my maximum and my minimum are going to add the 0.04, so that'd be 0.651, and then it would subtract the 0.04 to get the minimum, so that would be 0.643, and then I need to figure out what my percent is, so I'm going to do 0.004 of 0.647 is what percent over 100. I want to figure out what percentage that is. So 0.004 times 100 divided by the 0.647, and I get 0.618. That is my percent. So I say that this is plus or minus 0.618%. I'm going to double check that math again. 0.004 times 100 divided by 0.642. I'm trying to, 647, sorry. And yeah, so that's what I got, 0.618. So that's going to be my percent increase. It's less than 1. This percent is going to be smaller, same concept though. So I'm going to go with that. Max would be added, 0.648. Min would be subtracted, 0.646. Then I have to figure out what 0.001 out of 0.647 is. And so 0.001 times 100 divided by 0.647 gives me a 0.15-ish, so plus or minus 0.15. Well, now on this last one, they're going to give me the percent, so it's plus or minus 0.2%. So what I need to do is go in the other direction. So 0.2 out of 100 is what piece of 0.647. So now I have the percent. My cross multiplying is going to give me that plus or minus value that I'll add and subtract. So I'll do the 0.2 times 0.647, get that answer, divide by 100, and it's 0.001294. So I'm going to go plus or minus 0.001. I'm just going to go to 13. And then that's what I'm going to add and subtract. So 0.0013 plus 0.647 is the 0.6483, and then the 0.647 minus the 0.0013 that I got from figuring out that percent is 0.6457. Okay, and the rest are kind of the same, basically the same. You just have to work your way through the problems. So if you have any questions, just shoot me an email. Good luck, and I'll talk to you later.